So this is Isaiah 6 through 8. Then one of the angels flew to me with a live coal in his hand, which he had taken with tongs from the altar. With it he touched my mouth and said, "See, this has touched your lips. Your guilt is taken away and your sin is atoned for." Then I heard the voice of the Lord saying, "Whom shall I send? And who will go for us?" And I said, "Here I am, send me." This is our last section, section 9. We did every section in this chapter. This section is basically about statistics. Let me explain what statistics is about. If you wanted to know what people's opinions are in America, we'll say, you could do any country, you could do China if you want, but let's say you wanted to know what % of people in America believe in God. Now, there's two ways that you could try to find that. Number one, you could ask everyone in America, do you believe in God, yes or no? That would take a long time to ask 400 million people. It'd take even longer in China, where there's 1.6 billion people. It'd take a long time. It'd take a lot of money. You got to be paying someone to go around in all these villages and cities and towns and all these different places to ask people. So it'd take too much time, too much money to ask everybody in the whole population. So what statisticians do, people who use statistics, they are looking for a sample, a smaller group of people that's representative of the whole population. When I say representative, I mean something that's not like this. If you go to Shadow Mountain Church and you ask people there, do you believe in God? It's probably going to be a really high percentage, say like 99%, maybe 95%. A lot of people, it might be 100% in the end. A lot of people are going to say they believe in God. The sample, asking people at church, is not representative. It would be a biased sample. It's biased because, well, you're asking people that go to a church, and they probably go to church because they believe in God. So you would need to try to get a random sample, an unbiased sample that's representative of the larger population. So rather than asking people at church, you might ask people at the grocery store, ask people at the mall, ask people in different places in the community to try to get an idea of what % of people believe in God. So that's the difference between a population and a sample. A population is everybody in a certain group. So you could talk about our school population, 400 students in our high school, that population, and maybe one sample could be this class. This class might not be representative of the whole school, though. The sample would be a small part of the population. So just a little picture, something like that. So you're trying to find a random sample, which is known as an unbiased sample. So a sample size n is random when every possible sample size n has an equal chance of being selected. For polling organizations are organizations that go out and ask people their opinions on religion, on the government, on social issues, on a bunch of different things. For polling organizations, to ensure that a small sample is representative of a larger population, they want to obtain an unbiased sample. So they don't want to get a biased sample. That's bad. They want an unbiased sample. So here are some examples. Many of these examples are biased. There's a problem with many of these examples, just to show you what the problem is. And we'll talk as we go along how to maybe make them better than what they are. So state whether each method of sampling would produce a random or unbiased sample and explain. So letter A, asking every 10th person coming out of a health club how many times a week they exercise in order to determine how often people in the city exercise. So the problem with this is that you're asking people who are going to the health club, to the gym. They already exercise a lot. So you can't say, oh, I'm asking these people coming out of just exercising, how often do you exercise? That would be a biased sample. Letter B, surveying people going into an Italian restaurant to find out people's favorite type of food. That would be biased because if you're asking people that are coming out of an Italian restaurant, they probably either prefer Italian food, like spaghetti and stuff. Or it's, they really like it if it's not their favorite. So it's not a great way to do that. A better way to try to figure out people's favorite type of food, you could go to a variety of restaurants. Probably maybe better than that is just asking people not at a restaurant, just asking people at the mall or something, what's your favorite type of food? Those would be better ways than this of trying to figure out people's favorite type of food. Letter C, surveying people going into an action movie to find out the most popular kind of movie. That would be biased. You don't want to just ask people who are going to see Iron Man 3 coming out this Friday or Saturday, Iron Man 3. Because they probably like action movies. If they're seeing an action movie, they probably like an action movie. So the action movie is a problem, so this is biased. Calling every 10th person on a list of subscribers to a newspaper to ask about the quality of delivery service. So this is our first unbiased with a catch. It's good that they're asking every 10th person on a list. So it's not like they get to choose who they're asking. They're not just asking the first people on the list. It's every 10th person about the quality of the newspaper. The only problem is, what about the people who unsubscribed? How do you spell unsubscribe? The problem is, what about the people who unsubscribed because the delivery service was really bad? So you're not going to ask them. If you're only taking people who subscribe, what about the people who said, I don't want the newspaper anymore because the delivery service stinks. I'm waiting to get my newspaper and they deliver it 5 hours late. So I quit. I don't want this anymore. So you want to somehow ask the people who unsubscribed, is it because of the delivery service? But otherwise, we could say this is unbiased. That's kind of just like a little thing to think about. Asking students on a Christian campus about God and the Bible to determine religious views of teenagers. This would be biased because it's a Christian campus. You could change this. Maybe if it said like public school campus, that might be a better representation of teenagers in America or whatever country, public school. You could also, instead of doing public school, you could say, survey students on a Christian campus about the views of Christian school teenagers. And then it would be okay, it wouldn't be biased. You're asking Christian school kids, and your big population is Christian school students. So that would be a lot better, but the way it's worded would be biased. Letter F, predicting local election results by polling people in every 20th residence in all the different neighborhoods in the community. This would be unbiased. This is random, which is good. Notice what they did. They are polling every 20th residence. Residence is just a house. Every 20th house. They ask people what their opinions were on the election, like presidential election. And it's all the neighborhoods. It's important that they ask all. They didn't just ask one part of town, the Republican part of town, or they didn't just ask this part of town that's the Democrat part of town. They asked every part of town, every 20th residence throughout the town. So everybody had an equal chance of being selected. Letter G, asking every 5th student who leaves chapel about what they thought of chapel that day. That would be unbiased. You're asking every 5th student. The only problem would be like absent students, but they weren't at chapel anyway, so they don't have an opinion. The other problem might be make sure that you're at different doors, because everybody leaves different doors. So you'd want to ask every 5th person from each door to make sure it's representative. You don't want to ask like the first 10 people. The first 10 people would be bad because on the one side they would be all freshmen. And freshmen might have a different view of chapel than seniors, especially since freshmen have to sit way in the back and seniors get to sit way up front. So that's how you get a representative sample, or those are some biased and unbiased ways. The next part, even if you get a random sample and a representative sample, you can't always be sure, 100% confident, that it matches what the entire population would believe about something. So if you take a small sample, you can be confident, but you can't be 100% sure. So we talk about something called margin of error, which we abbreviate ME. So as the sample size increases, it's more representative of the entire population. And the margin of error gives us a plus or minus bound on how close our estimate is. So I've given you a picture here. It's a nice color. And what I want you to notice is these are normal distributions. What we're talking about today is related to 2 days ago and the normal distribution. But specifically, notice when the sample size is really big, the margin of error is small. And this graph right here, the standard deviation is really small. It's really close. It's not spread out. It's really close. Notice on this one, when you have a small sample size, 96, you have a very large margin of error. So you could be wrong 10%, plus or minus 10%. So that's why you get a standard deviation that's really wide, a normal distribution that's really spread out. So the formula for margin of error is this right here, which I want you to memorize. It's a pretty simple formula. Compared to yesterday's, I think it's pretty simple. So you have the margin of error, ME, equals 2 times the square root of P. P is usually the percent who responded, times 1 minus P, which is kind of like the binomial theorem, P times 1 minus P, divided by N is the number that you sampled. And that will give you margin of error, margin of sampling error. So let me show you how to use this on the next page. 2008 survey. I found this a couple weeks ago. 2008 survey of 400 randomly selected adults. 45 answered family, 45%, answered family as the most important thing in their life. What is the margin of error? So margin of error is what we're solving for. N is the number in our sample, which is 400. P is the probability that people responded family on this question, so 0.45. 1 minus P is 1 minus 0.45, is 0.55. And that's all the variables that we need. So the formula is margin of error equals 2 square root of 0.45 times, so success times failure, 0.55, divided by 400. And it's actually pretty easy to do on your calculator. You don't really have to worry about parentheses. You have 2 square root 0.45 times 0.55 divided by 400. So you get this, which you would round to 5%, 0.05. 0.05, which is 5%. So the margin of error is 5%. What that means, it's really a plus or minus 5. So this means that between 40% and 50%. I got those numbers by taking 45 plus or minus 5%. So between 40 and 50% of the entire population would say family is the most important to them. So we don't know for sure what the entire population would do unless we ask them all, but we can be really confident that somewhere between 40 and 50, the entire population would say somewhere between 40 and 50%. How about you try the next one? This is a 2013 survey. I think this was in March. It showed that 50% of Americans approve of the job that President Obama is doing. 1,500 people were surveyed. What is the margin of error? So see if you could do that. So margin of error is 2.6%. So this means that you would have 47.4% to 52.6% who support Obama or like the job that he's doing in office. So from the population, it gives you a window. The population would support Obama somewhere in that interval. Okay, the next question we have is, on 2008 survey, 17% of Americans said money and career were the most important things in their life. The margin of error was 3%. How many people were surveyed? Notice we're asked to solve for a different variable, N. Margin of error is given to us as 3%, which is 0.03. the percent that responded positively was 17%. 1 minus that is 0.83. So when we plug the numbers in, we'd have 0.03 equals 2 times the square root of 0.17, 0.83, divided by n. And we're solving for n. So see if you could figure out how to solve for. So you would get 627.1. In this case, I know it's kind of strange, but in this case, you actually want to round up all the time, regardless of the decimal. You have to make sure that you get this margin of error into given this percentage. So if you round down, the margin of error will be slightly off. So you actually want to round up to ensure that you get this particular margin of error. So you actually need to survey 628 people. As one of the few times that we round up with a decimal like 0.1, but you need 0.1 of a person, but there is no 0.1 of a person. A person is either a person or they're not a person. It's either a dog or a human. There's no like in between 0.1 kind of thing. So anyway, that's 628 people. How about you try the next one? Read that example and try that. So 74 people would respond.